I'm Anil Kumar, and here is another example on one-side limits of function. So we are following a very standard approach, and that is going to be repeated for different examples. I hope that helps you to understand the concept. Given function f of x equals to cube root of x plus 2. So we have a transformed cube root function here, 2 units translated horizontally left. Sketch the graph of the function. Then we need to find limit of this function as x approaches minus 2 from the right side, x approaches minus 2 from the left side, and determine limit of this function as x approaches minus 2. So let's begin by sketching the function itself. So first I will sketch the cube root function, and then we will translate it horizontally to get the graph for the given function, right? So cube root function, like square root, it kind of goes like this, and then over here is kind of like this. So important thing here is that we have a vertical tangent at x equals to 0 for a cube root function. If it is a cube function, then it's kind of x-axis is the horizontal asymptote. In this particular case, y-axis is the vertical asymptote at x equals to 0. So that is very important as far as the shape of the graph is concerned. I'm not really bothered about the accuracy here. You should be plotting it on a graph paper with some values, and good values to take for a cube root function are 0, plus minus 1, plus minus 8, for example. These are the good values. Anyway, we are understanding the concept. So let me move this 2 units to left. Let us say this is 2 for us. Then the graph of the cube root function will be kind of like this, right? And it's very enlarged view, correct? So that is the function. And here, this point which we are considering is minus 2. So that is the x-axis, and this is our function f of x. F of x is cube root of x plus 2. That means cube root function translated 2 units to left. So that is part A, sketch the graph of the function, right? Now, the thing is that we need to answer all these questions. Part B is limit of the function as x approaches minus 2, plus here means from the right side. So when you are approaching from the right side, which value do you approach? You actually approach 0, right? So that means if you are approaching from the right side, then let me show you. When you are approaching from the right side, you hit the graph here and you approach a value which is f of x equals to 0, right? So the answer here is you're approaching 0. Now, part C is determine the limit of the function as you approach minus 2 from the left side. That minus indicates left side. So from the left side when you approach, then you are approaching also 0. Now since from both the sides you are approaching a fixed value of 0, the limit exists at minus 2 and the limit is also 0, right? So that is what the limit is for the given function. You will note it is a continuous function, right? Now the value of the function at minus 2 is also 0. Now if the value of the function is equal to the limit of the function as x approaches minus 2, right, then what do we say? We say the function is continuous, right? So that is additional information which I am giving you. At times it may be required in such questions, right? Part E could be explain if the function is continuous or not. Now since the value of the function is same as the limit of the function at a point, it is continuous at that particular point, right? But I think you understand the concept of finding limit, approaching a value from left side, right side, and comparing them, right? So that is the whole idea of this exercise. Let's move on and do some more questions. Thank you and all the best.